We're now starting chapter 9. It's actually entitled Momentum and its Conservation. So you should go to Notability. You need to download these 3 documents. In Notability, you should create a chapter 9 subject under your honors physics. And you need to download those 3 documents, chapter 9 objectives, definition graphic organizer, and the intro questions. We're going to do these 3 today. Once you get those downloaded, open up the chapter 9 objectives. I'm going to use paper here so I can write the information I have on here. And so again, this is chapter 9, Momentum and its Conservation. You can see this a little better. And today we're going to look at these first two objectives. Define momentum and impulse, and explain the connection between Newton's second law and the impulse momentum equations. We're going to take a look at those. First, we're going to talk about momentum and do a little research about momentum and impulse. Now, sometime in your science educational career, you have probably talked about momentum or learned some things about momentum, so this probably isn't a new concept to you. Impulse might be a new concept, but momentum should not be. So we're going to have you reflect back on your past science education and see if you can remember things about momentum. So the next document you need to open up on Notability is this document, the one entitled Definition Graphic Organizer. It looks like this, right? We're going to do a little activity here. Now, you need to actively take part in this activity in order for it to be a benefit to you, because it's a pretty interesting activity. It helps us understand some things about momentum and rely on our past experiences to learn better. So this is called a definition graphic organizer, the technical term of it. But basically it works like this. What I want you to do, in this middle square right here, you're going to write the word momentum. That's the word we're going to be analyzing or trying to understand. That's a concept, a significant concept in physics, in fact. What I want you to do is take a minute or so, and up here in this upper left hand, I want you to write the best definition of momentum that you know. Do not look it up. Don't go to any internet website to find it. Just based on what you know, write your best definition of momentum. Give it your best shot, all right? It doesn't have to be right. Just give it your best shot based on what you know right now. You can pause the video and do that. All right, once you have this definition written, I want you to come over here. This got a little word cut off here. In the upper right-hand corner of this graphic organizer, I want you to write all that you know about that word momentum. Anything that you recall from past science classes, anything that you've read, or anything that you're familiar with. Just you can write bulleted list, just from memory, what you know about momentum. Again, it doesn't have to be right, but anything you know about momentum, write in that space right there. Pause the video. Take a minute or so to write everything that you know. Try and get at least 2 or 3 things about what you know about momentum. Anything at all, okay? So pause the video, take a couple minutes, see if you can do that. All right, so now we've done these first 2 sections. Now let's come down here to the bottom left. What I want you to do is, as best as you can, draw a diagram of what you think represents momentum. The best diagram you can. It can be simple, it can be complex. And again, your artistic talents don't need to be as good as mine, but draw the best diagram you can of momentum. Again, pause the video, take a little bit of time to do that. It doesn't take long, you don't only spend a whole day on it, just draw the best diagram you can about momentum. And then, all right, pause the video, and you can start it back up. And then up in the bottom right-hand corner, you can either write a description or draw a diagram of a non-example of momentum, something that is not momentum, something completely out of there that's not momentum, anything at all, okay? So again, pause the video, take some time to do that. All right, you start back up. Now, keep this, don't delete it or change it. You have to have this filled out in order for this to work properly. What we're gonna do as we go through momentum and go through the rest of the chapter, at the end of the chapter, you're gonna come back to this, and after we get done all this, you're going to redo this and see how much you've improved from what you did at the start. Okay? So now, let's continue on. Open up the 3rd document. This is called Intro Questions. So what I want you to do is in a little bit you're going to pause the video and you're going to use the internet to search answers to the following. You're going to search the internet, define impulse. And again, this is a scientific definition of impulse, all right, not a societal definition of impulse. Write the equation for impulse and all of these things as best you can, okay? Do an internet search, and then when you get done with that, come back and you can pause the video, come back, and I'm going to show you some of the things that I have written in these spaces. And if you don't have something like that, I want you to write them in so we all have similar terms and similar definitions to work from, okay? So go ahead and pause the video and do that, and then come back. All right, you've answered. You should have all 8 of these spaces filled in. Let's take a look. And we're going to go through this. There's a second page to this called Notes and Derivation. We're going to take some notes here in just a little bit after we go through these 8 statements. Just also remember, you're going to be taking a quiz over this information also today. There'll be 5 multiple choice quiz questions based on this information. First one, define impulse. Impulse is a vector. If you don't have that, make sure you write that down because impulse is a vector. Very important to know that it has magnitude and direction. Determined by the product of the net force. It's very important that you have net force there, not just any force, and time. The equation for impulse is impulse equals net force times time. Make sure it's net force times time. An example of impulse is if someone hits a baseball or kicks a soccer ball or throws a volleyball or anything like this. Those are all examples of impulse. There are many examples of impulse. You throw something up in the air and it comes back down. All that motion is impulse because there's a net force acting on it for a period of time. And the definition of momentum. Momentum is mass in motion is a kind of a common definition for that. It is a vector quantity, just like impulse is. There's a reason for that. It's determined by the product of the mass and velocity of an object. You have an object moving that has mass, of course. If it's moving, it has velocity. The mass times the velocity is the momentum of that object. If I didn't say change momentum, that's the momentum of an object. The equation for momentum is just mass times velocity. This is momentum, not change of momentum. An example of something that has momentum, a moving car, or you can describe anything that's moving has momentum. And then number 7, describe the relationship between impulse and change of momentum. Impulse causes a change of momentum, or you can say it's equal to a change of momentum. That's very important to understand. Impulse is net force times time equals mass times change of velocity, which is a change in momentum. That's a little delta triangle there, change in momentum. Impulse, mass times change of velocity, change in momentum are all the same thing. Very important to remember. Describe an example of impulse causing a change in momentum. A bat applies a force to a baseball, causing the baseball to change its momentum. In this case, primarily velocity. Anything that has a net force applied to it and its velocity is changing is an example of an impulse causing a change in momentum. Okay? Now, make sure you have this information. You can pause the video at any time and make sure you have this information down along with the information that you wrote. Kind of check what you wrote compared to what I have and hopefully make sure it makes sense. All right, now, we're going to go to the second page. There we go. This page right here. We're going to do some mathematical derivations. Now, if we get done with this, on the first page of chapter 9 on the LMS are also some video examples of impulse. Again, you can take a look at those after we get done with this. They help enforce what we're doing here. So let's start with the derivation. Again, we don't do a whole lot of derivations in honor physics, but I think this is worth the process of going through. We're going to start with Newton's second law. Net force equals mass times acceleration. And the subjective right here says, explain the connection between Newton's second law and the impulse momentum equation. That's what we're doing right now. So this is Newton's second law. We have an acceleration equation, v final minus v initial over time. Again, that comes from this equation, v final equals v initial plus acceleration times time. I just rearrange this equation, solve for acceleration. That's how I get v final minus v initial over time. I'm going to take this quantity here and substitute into acceleration for this equation. So this is going to be net force equals mass times v final minus v initial over time. I'm going to rearrange this equation a little bit. I'm going to move time to the other side of the equation, so I have to multiply both sides of the equation by time. This becomes net force times time equals mass, times V final minus V initial. Okay? I'm going to change this just a little bit. Again, this is net force times time. I'm going to expand this out, multiply through by mass. It's going to be mass times V final minus mass times V initial. Okay? Now, this quantity here, this quantity, net force times time, is what we call impulse. Okay? So I'm going to write this. So then this equation right here, net force times time, on the left side is what we call impulse. And this is mass V final minus V initial. Of course, this right here, final minus initial, is change in velocity. So this is impulse equals mass times change in velocity. This is another form of the impulse equation. Right? So now, I'm going to write several equations. So far, all these equations are really the same equation. In fact, when Newton first wrote his second law of motion, it was actually in terms of momentum and impulse instead of net force and mass and acceleration. There's a little historical context there. So now, I'm going to continue on with this right here. Again, this is impulse, which is net force times time. The left side of the equation is impulse, equals, this is m times v final. Mass times velocity is what we call momentum. So mass times final velocity is actually the final momentum. Mass times initial velocity is actually the initial momentum. So impulse equals final momentum minus initial momentum. And final minus initial anything is the change. So this is the impulse equals change in momentum. Remember, impulse causes a change in momentum. This quantity, mass times velocity, is called momentum. Mass times object velocity is momentum, a very significant equation. So here's an impulse equation. This is the momentum equation. And remember, impulse, as we drive up here, impulse is net force times time. So impulse is net force times time. This is the impulse equation. This is the momentum equation. This is the impulse equals change in momentum equation. Again, these are basically the same equation. In fact, this is also the same equation as this, if you understand the process that we're doing. Now let's take a look at units. Momentum, mass is in units of kilograms, velocity is units of meters per second. So the units of momentum are kilogram meters per second. Impulse, net force, look at the units of impulse, are newtons, and time, time is seconds, Newton dash seconds. Now, if impulse is the same as change momentum, then these units have to be the same. How can one unit be Newton seconds, the other units be kilogram meter per second? Let's take a look at Newton seconds. Newton seconds. A Newton is a kilogram meter per second squared. Remember, from Newton's second law, this is kilograms, this is meter per second squared, so Newton is a kilogram meter per second squared, kilogram meter per second squared times seconds. Multiply this by seconds. This second cancels one of those, and look what we have. A Newton second is the same as a kilogram meter per second. So a Newton second and a kilogram meter per second are really the same units. Usually, by convention, which means what's usually done, impulse is usually written in the units of Newton seconds, and momentum, or change in momentum, is written in the units of kilogram meters per second. So the main equations you need to know are the ones that are in this box right here. Right? And so that's our derivation formula. Take a look at, there's another section on that page of example videos or demonstration videos of impulse. Take a look at those, and we're going to use those videos to understand this impulse change in momentum, impulse change in momentum, impulse change in momentum, and how that affects an object when its momentum is changing.